Okay, thank you. Good morning to everyone. So please don't hesitate to stop me if you have any questions. So I'm going to open Mathematica. So Mathematica is this interface you see here that allows you to do computations, write also articles, since you are journalists. It's like a document that you can share in the web. You can export it as PDF and many other formats. So let's start by adding a title here. For example, I don't know, data analysis with Mathematica. Okay, so I select from this menu here the title cell. Then we are going to create a first section, maybe introduction. Okay, I can save this file. For example, I can say save, I don't know, journalism. Okay, so here I have my file and I can do many things here. I can work with units, for example. So this is important to you because you have to sometimes compare different quantities. So I can create, for example, a quantity. Okay, here you can increase the zoom if you want of the text. You can, of course, take all the content and maximize the window. And here, for example, I want to compare 10 kilograms with, for example, 20 pounds. Okay, so is it bigger 10 kilograms or 20 pounds? Well, we can ask the question. Here I can say, is this smaller than this? And I get an answer. This is false. So that means that 10 kilograms is bigger than 20 pounds. We can, for example, want to know how many kilograms are 20 pounds. So I can say unit convert my 20 pounds into kilograms. This is the exact conversion. If I want to get a numerical value, I can use the menu I see here, click on numerical value, and you can see that we have exactly the same output here, but with the n function that allows you to evaluate decimal numbers. So 20 pounds are approximately 9 kilograms, okay? So this is one example of things you can do with Mathematica. Now, let's try to move to a different case. So we were talking about data and data visualization. Okay, for example, I can say here a section, use the data from Wolfram. At Wolfram, we have a database that contains many sub-databases about many different topics. We can talk about Google, for example. So you can say financial data, Google. Okay, so this is the Nasdaq stock price of Google right now. Here you need the internet to access to this information. It's going to take the value.
With the question. Interrupt you with the question. So you typed financial data and then Nasdaq, but you didn't type Nasdaq. It came up by itself. Can you explain what was going on there?
Yes, in general, when you start writing something, you have a completion tool that suggests different possibilities. So for example, if I say L and then I have a suggestion here, which is line, list, lighter, different things. And in the case of financial data, if I do fin, I have this financial data option. I can choose it directly by setting enter. And then here, when I introduce the guillemot, what's the name of guillemot? I don't remember. Well, you understand this symbol? Mhm. I have many different options here. I can see the options. So, for example, this one is Tesla. This is Amazon. And
sorry,
probably
I stopped you because this is quite important. If they want to look up stock option, not stock option, stock data of today. So first of all, is this data real time? And second, how did you came up with this window with all the tickers?
yes. So this data actually real time means different things in the financial setting, because this data is true like now, but now with some milliseconds of delay. So if you don't care about milliseconds, like for example, you want a precision of the order of 1 second or 1 minute, this value is true. But this value is not true if you are interested in the very, very exact value at each millisecond. So in fast trading, algorithmic trading, each millisecond counts. I think for journalism, this is not actually important.
Let me explain this concept, which is important. For us as journalists, it doesn't matter the milliseconds, because at most we will write articles that say, I don't know, Google has went down because of the war in Ukraine or something, okay? And it doesn't matter if it happened 1 minute, microseconds before or later. So that's okay. And the ticker, the things that he's using, GOOG or TSLA, are the symbols of the companies on the stock exchanges. Every company has a long name, Tesla, and the ticker, which is in this case 3 letters. So this is what. Sorry to interrupt you, but so it's what we are doing is clear.
Yes, no problem. Thank you. So here I just get the value right now of Google, and probably I want to obtain this the historical values of this stock. So I can give here an interval of dates. For example, I want from January 1st, 2020. So I can say here, date object 2020, January the 1st, up to today. This is going to construct an object which is time series. And this object can be actually plotted with the function dateListPlot. So you say dateListPlot and just take this output here. I can use my my buttons here, copy the last output, copy the last input. So I copy this here, and then I evaluate the plot and obtain this result. So from 2020 to 2024, this is the actual evolution of the Google stock value. We can add several options. For example, let's say I want to add some labels. So I can say here, plot label, evolution of the price of stock Google. So this is going to add this title here. I can also ask for a grid lines automatic. Probably I want to see some filling of the plot to see here colorized. Okay. Probably change the color, for example, plot style, red instead of blue. And you can add as much as options as you want. Okay. Okay, so this is an example from the data directly from Wolfram. There are many other interesting things in the Wolfram data. We can speak, for example, about planets, planet data.
Before going ahead, let's say we are happy with this chart, the red one, and yes. I wanted to incorporate in my article, which I'm doing in, I don't know, Word, whatever, or maybe you know, WordPress, something. So how do I import the thing?
So you are going to use the function export. Okay, so export takes the name of the file, for example, my plot of Google. You can add the extension you want. So for example, I want a PNG extension. And then here you just copy the input of the thing you want to generate. Okay, so export the name and the code of what you want to export. It is here. And as you can see, it's here in my documents, my plot of google.png. And from here, maybe I'm working in Word and I want to insert my plot directly into Google, into my Word. So I can do it in this way. And there are many options, many different file formats you can export it. Here I decide to use PNG, but you can export in PDF, JPG. Here's the list, the complete list of the formats you can use to export something, not necessarily an image, but many different kind of objects.
Many formats exist in the world. I don't know. We are amazed about so many formats. Let's see. Let me ask if everything is clear so far, because it's important that we are not missing anybody. We have a question?
Yes, please. I've just tried to replicate some of what you did, like with the graphs. When you put in an input, do you just click enter and the output straight away comes up? Because that's not happening for me.
Yes, thank you for the question. I was too fast. So when you enter an input, for example, 2 + 2, you have to press simultaneously the keys Shift and Enter. Okay, so Shift is the key just under Enter. So you simultaneously press Shift and Enter.
She has a red. Can you share your screen? You can.
If she wants to share the screen, you have to be in the Zoom session.
No, she's not. I'm the only one in. Let's see if she can. Can you see anything here? No, we need to share. But anyway, she has a red red thing, so I think there is an extra parenthesis. Maybe. So try to join the.
I think here the error is a syntax error. So there's something.
Let's do this. Sorry, let's do this. She will join the call so she can share the screen, but before, so go into the chat, you have the link, and please accept her. I want to ask the other people, everything is clear so far, or are we going too fast?
It's a bit speedy,
but yeah, I suspected that it's a bit speedy. So my suggestion is let's stay on the financial example, which is quite good, because it's something I wanted to talk about later. And maybe
do it one more time for one example.
Yeah, make sure that everything is clear. So if you can roll back a little bit in your presentation.
Yes.
So first of all, when you instead of typing enter, you have to type shift enter. So two fingers at the same time, and that means please Wolfram Alpha or Wolfram in fact Mathematica reply to me. Don't just wait. Yeah, okay.
Yes, you might try this first one.
Okay. So if you type financial, and the other thing interesting is that there are all these. I'm not sure if you do you call them function verbs or what? Financial data.
Functions.
How do you call that?
Functions.
Functions. Okay. So there are these functions, and there are an incredible amount of function that does everything in the world, I guess. So it's hard to understand which one to use, but we will go back to and ask him how to do it later. Okay. So far, our example is on financial data. So in this situation, your task is to write an article about, let's try to make a real case. We want to compare the performance of Google versus the performance of a traditional stock, maybe ExxonMobil. So just to understand, because the article is about how better or worse is the tech sector going on the stock as compared to a traditional sector. Okay, so the first thing we want to do is to get data from Google, and he did it with this thing, financial data Nasdaq Goog. Okay, did you get the data?
Yeah.
On your computers? Same results, hopefully. Okay.
Does Julia wants to share a screen quickly, or?
Yeah, I can.
Okay, so now, yeah, you can share if you want.
It's
Good.
telling me that I've got no opening, but
Yes, here the mistake is that you have this
Brackets?
this bracket just after Google. You have to take out this bracket after Google, Nasdaq Google. You have to delete that one, and you have to add it at the, now you can evaluate this.
So shift enter. Good. So the concept, because they're journalist or mathematician, is that every open bracket has a matching closed brackets. Sometimes you have 3 open brackets, and at the end, close, one after the other, because they have to be balanced, okay? And if they are square brackets, they are different objects as compared to the graph. How do they call it? The other type of bracket.
Curly brackets.
Round bracket.
No, curly.
Curly, okay. Curly, round, and square. Okay, so it must be balanced. So did you get the results?
well, here it's
Curly is dynamic evaluation.
Okay,
so here it's working for Julia. It's working. It's just downloading the data. So the first time you run the code, it can be slow, like here. It also depends on the speed of the internet, but don't worry, it's working and it's going to come.
okay. Thank you.
Okay, so we can switch back to your screen, and then we tell you if she gets the results or not. Anyone else try?
Thank you.
You did?
It worked. Ah, did it work? The second one, no? The one at the bottom. See, now I don't know how to turn it into a.
Let me show. Let me see.
Please plug what.
So essentially here you have 2 possibilities, okay? Here I just use the copy paste option from here, input output. You can see here, this is input 7 and this is output 7. So if I click in output, it's going to copy this thing. And if I click in input, it's going to copy the input association. So here, instead of doing output, I can click on input. So it's copying this here and I get exactly the same result. Okay, so it's 2 different ways of doing the same.
So just to update you, a few of them have the time series and a few didn't. Maybe at this time, you know what? So I propose this. We go into the situation of your computers later, because it's a waste. It's a pity to waste heaps time. We have more time alone, and we check why you, for instance, don't have the data and you do. But before, it's important to me you explain this thing called time series, because I'm not sure everybody understands why we have this funny square with a little graph, and what is a time series, in fact.
Yes, so in Mathematica, many objects that contain information and different kinds of informations, they are packed in symbols like this one, okay? So a time series is essentially a list of numbers with dates. So here, the time series is the value of the stock of Google at each date during this period, okay, of time. That's a time series. There are other objects, essentially we are not going to encounter today, but they are packed similarly as this, okay? So for example, when you solve differential equations, etc., the solutions are packed like numerical functions. So, well, when you see, the important thing is that when you see something like this, that means a gray rectangle with images or things, you have to think that it's an object which packs many informations. Okay, so here in particular, we can see some of the informations it contains, but it contains many more. We can see what's the output dimension. It's just one because we have just one value. If it was other thing, like for example, the value of Google, Tesla, and Microsoft, it's going to be an output of 3. The minimum increment is every day. So here we don't have the values each second, for example. Here is just every day. I can change that here if I add an option to have the values every second or every given period of time. So that's the minimum increment. There is no metadata here, but you can have metadata. For example, with images, you have metadata of the location of from where the image or the picture has been taken, etc. Okay. So that's.
Well, let me stop for a second again. So because I think this today is quite important. We got a graph, a chart with the number for, I think is the closing, which means the value of Google at the end of the day, of the closing of the stock at 6 p.m. or whatever, 9 p.m. I'm not sure. It doesn't matter. And this is useful if your article is about how Google compares to Exxon in a 10 years, 2 years, what we have here, 4 years time frame, but says that there is a specific event, the war in Ukraine starts, and you want to look at what happens the very day that the war in Ukraine starts. Can anybody remember what day it started?
23rd February.
Can we look at what happened to Google at that very day instead of doing the same graph but 24 hours on the day of the start of the war in Ukraine?
Yes, can you please remember me what's the date of the war?
Yeah, they know, and it was the
23rd of February, maybe?
February 23, they say.
I don't know if I think it was that day, but I'm not 100%.
Let's check.
It was 2022 or 2023? 2022, I think, right?
It's an old story. Yeah. Let's see if we get
24th February 2022. So I was off by 1 day. It was the 24th of February 2022.
Oh, I got 20. Officially began. I know that when the next day is so complicated. Okay. When the next
24th, but it was in the night, so that's why I said 23. But it was 24 in the morning, at 1 in the morning or something.
Okay, so maybe we want to do the 2 days before and 2 days after, I guess, to have some data.
So here we have from February 20 to February 28.
Okay. So we see, that's interesting. You see that on the 23rd, something strong happened, which is, so I guess that we can now say, okay, let's look at it for the entire month of February, maybe. Can we do that?
Yes.
From February 1st to maybe March 15 or something. Okay. So you see, I think that what we are seeing is that the market knew that a war was coming because there were Putin was putting his weapons around Ukraine, and then it happened. And we can see the result, the effect on a stock, which is interesting. But the point for Mathematica is that, and you will never get this from an article if you cut and paste a chart from somebody else's article, because you can iterate You see, and I will say, okay, let's see in 1 year, in the entire year, what happened. He can change the date from the beginning of 2022 to the end of 2022, and we see what happened. So that's why I'm saying these tools are important, because you can get data elsewhere, but you cannot get the possibility to drill down, to understand the data and change the scale and these kinds of things. So
Mario, maybe it's the right time to introduce the manipulate function, just to show them that you can actually interact with some of the parameters. And
yes, that's right. You're completely right. Let's do something with respect to GDP of countries. Okay, so for example, here, if I say country data, France, and you want to know the GDP. So the GDP, so in French is the PIB, Produit Intérieur Brut. France is 2.6 10 power 12 dollars per year. Okay. And you want to do the same, for example, for several countries, the G7. So country data, G7, you know, it's the collection of those countries. So Canada, France, Germany, Italy, Japan, United Kingdom, United States. And let's say
why are they in yellow boxes? Why are they in yellow boxes?
Yes, so the yellow boxes are actually something called entities. This is a very, very important word, so I'm going to use a color for my cell, a yellow color to say entities are the computational representation of concepts. So, for example, here, France, this yellow box here is an entity of a country, okay? And the country is France. So you can see this is a yellow box. Now, why this is useful? Well, entities contain many properties. For example, here from France, I can know the values of many properties you're going to see here. Okay, so I have, for example, the agricultural irrigated land fraction. I have the average yield. I have the annual marriages, information about army, information about birth rate fraction. You probably heard recently that France is having a sort of program of increasing the birth rate fraction. So those are all the informations you can ask about France. So let's take that particular example, birth rate fraction. So I come back here and I can copy France and say, I want from France, what's the value of the birth rate fraction? So it's 0.011 people per person per year. Okay, so this is the fraction, the rate fraction of births. Now, if I come back to my...
If we want, let me ask a question. If it's just curiosity. If we want to know the average birth rate of a woman, we would need to do that for the times the average number of years that the person lives, divided by 2 or something. No, times the number of people in France divided by 2 or something like this.
It's
because this looks funny. Usually we know that a woman does creates, I don't know, 1.8 children average and not 0.011, which looks funny. But because it's one for every year, right? Is this correct?
Here is people per person per year. And the computation actually is a little bit more complicated like that, because you have to take into account that the fraction of woman is not exactly the same of fraction of men. In general, you have in any population 51% of women and 49% of men. So this tiny difference has to be taken into account if you want to retrieve the correct answer to your question.
And sorry, from that very long list of properties, you just copy and paste one into the input. Is that correct?
Yes,
Thank you.
but it's
So
not the
if
only
we
way
wanted to,
of working with that.
so
And
if you want to
actually,
do the adult population is the number of people living here, I guess, right? So
exactly. So
if her question is, I want to know the population of France now, what does she has to type?
So there are two possibilities. One is you can say the quickest one is country data, then France, and then population. This is the fastest one. Now, if you want to work with entities, you can of course do something similar to this. And here you can retrieve the population ABCD
It was
GP population here. So instead of asking about, I can ask about population, so it's the same number. And there's a long form of this, which is entity value of entity of country, France, and then population. It's exactly the same, but it's the long form of this, okay? But it is the same.
But can I make one up, or do I have to choose one from the list of properties there?
Personally, I always use this one, which is the most simple one. They are equivalent, they give exactly the same result, and they are constructed internally exactly the same way. But it's up to you. What do you prefer?
okay.
But for
Okay.
the property, so I have the country data, France, and then the property in this example is population.
Yes.
But for my property, can I make up something, or does it have to be from the list that you have in output 23?
No, it has to be from this list.
Ah, okay. Yeah.
Because this is where they gather data.
Yeah,
Well, when you say make something up, you
Well,
a
for
number of cats per
Yeah,
family.
exactly,
If it's
exactly.
not there in the data,
Yeah.
you don't get
Okay.
it. And if they have the number of cats per family, it would be in one of those
Yeah,
boxes.
yeah. So it's best to first bring up the list of
Yeah.
properties and then, okay.
And see if
Yeah,
if what you're looking for it's there. It's it probably is, because you see how many.
yeah,
Sí,
yeah.
hostia.
No, they have a
But
lot.
maybe this specific example number of cats per family is not, or maybe it is. I'm not sure.
Maybe. Was traffic.
So we interrupted you a lot, but please go ahead.
Yeah, don't worry. Now, let me return back to my example of G7 country and the manipulate function. Imagine I want to create a table of this that constructs some information. So I can use manipulate. Here I'm going to say information about my country. Then here country. And then I say something like country is something inside the G7 list, okay? Now, when I evaluate this, you can see that I have here a menu from which I can choose the country, and it's going to give the information about the country, okay? Now, I have to define what the function information about my country is doing. So here I can say information about my country. So here, and this is the power of programming language, you can enlarge the possibilities of the language by defining your own functions. So here I'm going to say of a country is going to be, here is some syntax, but you will see it's pretty easy. I'm going to construct a column with some informations. What are those informations? Well, it's going to be country data of the country, and we're going to do the shape. And we are going to also, from the country, we want the flag. and we want, for example, the bordering countries. Okay, so this function here, information about my country, takes as input a country and returns a column with three informations, which are the shape, the flag of the country, and the bordering countries. Now I can choose from here, for example, France. This is the shape of the country, the flag, and the bordering countries of France. Okay. So the manipulate function allows you to construct dynamic interfaces of this kind with practically any type of object. So it can also be sound generation, it can be image processing, it can be almost wherever you want. Here's an example with some geography.
How can we make this box with also the population and the average GDP? Can we do it in the same box at right of the shape of France?
Yes, so for example, here I have to complete my column here. So you ask for the GDP. So I can say the same thing, country data, country GDP. And you asked for what else? The mean?
The current population, for instance. So how many
population, yeah, okay. Country population. So I just complete this, and you can see here it's automatically updated. Okay. Now Germany, this is the GDP, this is the population, and the bordering countries.
So say that I want to publish it on a newspaper. If I put it in the exponential format, people will not understand what the number. So can we have it in just an integer, let's say, instead of times,
yes. Yes, for example, here, if I take the Germany population, okay, I have this thing, right? And now we can transform this into million of people. So I can say unit convert this number into millions. No, it's the thing is that actually we use giga people. Giga people. People is with P. And now if you can say the numerical value of that. So it's this number, millions of person. But I think this was enough for you, no?
Oh, what I was trying to say is, I was trying to say it in the dollar, which is the GDP, you have 3.8 times 10 to the 12th. Can we express this as a number, as an integer without this?
Yeah, sorry. So it was the idea is the same. For example, here you can say I'm taking these outputs, or I'm going to use the input. It's the same. So you can say something like number format of this. Now I want to, well, the thing is, since this is a quantity, you have to use unit convert in any case. And then I want these giga dollars or trillion dollars.
Mario, you can't just have a numerical value, this?
No, they want to take out the power of 12.
Yeah.
US dollars. Trillion US dollars. It's already, yeah, it's US dollars per year. So here is divided by years. Yeah, for example, here you have $3.8 trillion per year. And also, if you don't want to take the quantities, you can use the quantity magnitude. So you say quantity magnitude of this thing. And then you transform that number using the number format. So this, I can choose accounting form, for example, and I have the full number. Okay. This is the same of this.
Okay, so let me stop you here because this is quite important. Maybe that I can express the concept like this. Out of Mathematica, you have always very precise data, and many times it comes up in an exponential format because that is the mathematical way, and it is not the format that you can use in your articles because people won't understand. So what he did was to use something called unit converter. And he's saying to this function unit converter that we are talking about Germany, the GDP, and missing how to explain the rest. You can type trillion, million, whatever you want. Is that it?
Yes.
Is that what you're doing?
Yes.
And we all know that the GDP, being a big number, is in trillions. It's not in millions. Okay. So that's why with this function, then you did US dollar divided by years. So trillion times US dollar divided by years. Is that what you did?
Yes. Because the GDP is in dollars per year, as you can see here.
Okay. Is this clear to everybody? Mm-hmm. So we are creating in fact, if you scroll back up a little bit, we have a nice graphic that we can use directly in one of your articles. Why not? And you just add the number on the right, and if it's maybe a sidebar in your article talking about Germany, this is the shape, this is the flag, this is the number of people, GDP. You have some basic data that you get in 1 minute or so out of Mathematica. And I guess you can export it in the same way that you showed us before, right?
Yes, and actually, let me just to finish show you. Since now the most of the articles that are published online, you can also, in a very easy way, export this into a web page using Cloud Deploy, which is a function that generates a URL from this code. And you will see that when I click on the URL, like this one, okay, it's open here my browser. And directly in this browser, I can manipulate the same object that it was in my notebook. I can choose, for example, United States. But now it's in a browser. And you can, of course, share this URL. So every person with this URL is going to be able to access to this this animation. Alex, do you want to say something?
Chat? No, I want to see if it works. Can you put it in the chat of? Yeah, of course, you're there. You're a journalist. You have to trust nobody. Okay, so this is a fact. So can you put in the chat the URL and we try it on our computers?
Yeah, sure.
And can you do the same for the graphs that you make?
Can you do the same for, sorry?
Or the graph, for example, the graph we initially made with the financial data.
Yes, you can do it with everything.
Okay, there you have
you
it.
Have to check the Marco that there's let me send again the link because it's broken. You have to now it's weird that there's a missing part. So do you see it? No, let me share it from maybe. Yeah, now it's
Oh,
good.
Now click that.
Okay, let me try.
Alex, est-ce que tu es par là? Alex Oppolini?
Oui, je t'écoute. Ouais. Tu veux que je clique sur le lien aussi?
Non, c'était moi je vais devoir y aller dans 30 secondes.
D'accord. OK. Non, pas de souci.
Okay, login.
Ouais. Bon, ben, ce qu'on peut faire, c'est, en effet, il est 15 heures, donc on va terminer la session. Marco, si tu
Oui.
veux éventuellement continuer cette session, on peut peut-être organiser un autre moment, peut-être un autre jour.
Yes,
Comme ça, on
let
peut.
me say this. Let me say things. We could benefit if your colleague shares the notebook he created with us. I think he can. Just save it and send it somehow. So we can try to do some exercises on the worksheet, on the notebook.
Yeah.
And maybe if next time, if you have a hour or so, we will do, because I think it's what works best, an example for maybe an article we have to write. So how do we, you see what I mean?
Yeah. That
So
seems to
that
be.
would be a way to go ahead.
Yeah. Okay. Yeah. We will send you the notebook. We will. Everybody has tried the link. The link works. Yeah. That Mario provided, so it's all working. And then we'll take it from there. I will send the notebook to you, Marco, and then you can share it with the students. And then maybe, like you said,
You're no longer busy. Show yourself.
Oh, sorry.
Here
we go. Sorry. Here we go. I was just saying we will share the notebook, and then, like you said, maybe next time you start working on it. You have some questions, and then we maybe spend some time, maybe half an hour, 3/4 of an hour, trying to answer the questions, and then we'll try to help you to make your document more interactive or more appealing. Yeah.
I think that they grasp the idea that it's perfect. That the power of how much data they can get. Now maybe with an example of a practical article to write, we can do if you're available another hour. But for the time being, we thank you. Thank you very much.
Thank you very much for having us. All right.
Bye bye. Thank you very much.
Take care. À bientôt. Have a nice afternoon.
Bye bye.
Bye.